Hey everyone, I hope you can hear me well. I'm using this microphone because I don't have a lot of equipment at this point. But in any case, we're going to do an integral. It's a little hard, I guess, but we'll see what we can do. It's ln of square root of x, all squared. Now, it's important to notice that this square isn't affecting only the x, rather the entire expression. So we're going to use integration by parts. The formula is u times v minus integration v du. However, initially we're going to make one u substitution. U equals ln of square root of x du equals differentiating ln of anything is 1 over that anything times du times the differentiation of that anything. So in our case, it's x to the power of half. So it's 1 over x to the half times 1 over 2x to the half dx. Then we put it in terms of dx because we're going to have to use that to substitute it into here. Dx equals 2 x half is just x, so 2x du. An important part of this integral is this distinction here. When here we're just going to raise both sides to e, or rather e raised to each of the sides. So eu equals e ln squared of x, and we're not like changing anything essentially, because if you do the same operation on each side, then everything is still equivalent. E to the ln of anything is that anything. We square both sides because we want the x alone. We get e to u equals x. This is important. This goes into here to this x. We get dx equals 2e to u du. We plug everything back in here. It's not an equal sign, it's an arrow. Some teachers will mark you wrong for it if you make it equal sign after you make the substitution. So just use arrows. This is going to be a u squared times, so basically this part is just u, and then our dx is 2e to u du. Now, as you can see, we're left with an easier looking expression because we don't have the ln. However, we do have a u squared here, so we're going to have to, this is where this comes in. I'm going to use u1. You can use a w, you can use any other dummy variable you'd like. U1, we're going to set equal to u squared. du1 equals 2u du. dv we're going to pick to be 2e to u. That means v is e to u. You can check by differentiation that those are equivalent, that those are true, they're correct, they're valid. You can, let's just make a 1 here even though we don't have a v. Following this, u times v, we have u1, so u squared times e to u. Minus integration. I like to put the bracket over here because we have a negative sign, and we want to keep track of that because we're going to have to integrate by parts again. Spoiler alert. v du. v du. e to u du. As you can see, we've reduced this expression to power of 1. So essentially we're going to have to do it again to get rid of the u altogether, and we're left with just an easy exponential in the integral. Do an integration by parts again. We get u2 equals u this time. du2 equals du. dv2, remember these are not the same because we're integrating by parts again. dv2, however, again, it's going to be the same thing here, though, right? So let me just clarify. Initially we had u squared 2e2u. Here we have u with no squared is just u, 2e2u. So it's like this part's the same, like the v's are the same, but the u is different. v2 is e2u again. There's a du here that I had forgotten to write. Okay, rewriting the expression. Following this again, we have u times v, u v, u e to u minus integral of v du. V is e to u, du is du. This we know how to do. This becomes, so look, let's rewrite this. So this factor is negative, and this expression is going to be positive because a negative times a negative. And when you integrate this last part, so up until this point, we haven't integrated anything really. So you'd think you'd get a couple constants here on the way, but no, this is the actual only time that you're integrating, where you're going to end up with a constant. So if you integrate that, you're left with e to u over 2 plus c. Okay? This is your almost result because we need to substitute our u back in. After you substitute it back, there's a property that you should know. When you have e to the ln of x, that always equals x. Also, 2 ln of x equals ln of x squared. So the 2 just migrates over here. Using those two, when we plug in u into here, or ln of square root of x, this stays the way it is because we can't operate with this 2. It's affecting the entire natural log, whereas this is only affecting the x. Times e to u. Well, what is e to u? E to ln x, right? We said that this, using this property, we can say that this equals x. Because the 2 comes over here, x to the half squared is x. E to the ln of x is x. So we can surely just put x here minus ln of square root of x. E to u, again, we just established that e to u here is going to be x. So times x plus e to u over 2, which is going to be x over 2 plus c. This is your final result. Yeah. So the most important part, I think, in my opinion, is this part where you have to make a distinction between, where you kind of have to have some intuition to raise these both sides to, where you got to raise e to those sides. A lot of people say raise those sides, or like raise an expression to the power of e. That doesn't make sense because then you'd have x to the e, or anything to the e. But if you want e to be raised to some variable, it's a little harder to say it, but anyway. So this is the most important part, in my opinion. And then everything else is just peanuts, really. Yeah, so if you enjoyed the video, please leave a like. If it helped you in any way, shape, or form, write a comment, say what's up, this and that. If you think I can improve on something, please do let me know, because I'm only starting up. And yeah, I hope you enjoyed the video. Have a nice day. Bye.